So all of you, please modify this. This is not cos ax by x. By overlook, I have done a small mistake. Tan ax by a. All of you, please change in the second formula, third term. Instead of cos ax by x, that is tan ax by x. Sin ax by x, tan ax by x, e power ax minus 1 by x. All these three equal to answer A. In this case, sin, cos, log. Answer 0 when x tends to infinity. In this fifth one, inverse of each term. 0 inverse is infinity. X inverse is 1 by x. Power 1 by x inverse is x. Easy to remember. E power AB. AB, n constants. Then I already explained L'Hospital rule. So when the quotient of two functions, when x tends to a, becomes 0 by 0, infinity by infinity, then differentiate numerator, denominator with respect to x, and then again apply limit x tends to a. That limit must be exist. So this is called L'Hospital rule. While applying this rule, in this case, second time also you will be getting 0 by 0. Apply the same procedure for finding derivative to numerator as well as denominator till the last step, that is existence, limit value existence. Okay, that means you may get this L'Hospital rule repeated procedure. Okay, repeated application. Now I am doing an example. So the first example, this question asked in 2014, limit x tends to 0, x minus sin x by 1 minus cos x. Now this term is not my one of the 7 standard limits. What to do? As I told in the problematic approach, when x tends to 0 means everywhere put x equal to 0, provided that exists. If you are putting directly x equal to 0, okay, that is called one step answer. Let us see. 0, sin 0, 0, 0 minus 0, 0, 1 minus cos 0, 1, 1 minus 1, 0. So this is giving 0 by 0. That is this. Then apply this. So this is 0 by 0 form. Okay. Now compare numerator and denominator respectively. This is your f of x and this is your g of x. So what I told, this is question. Now answer is f dash x by g dash x and then limit. Limit x tends to a. X derivative with respect to x is 1. Sin x derivative with respect to x is cos x. Divided by 1 derivative. Constant alone derivative is 0. Cos x derivative with respect to x is minus sin x. So simplifies plus sin x. Okay. Since by L'Hospital's rule, in short form I am writing LHS rule. Now once again 1 minus cos x by sin x. Is it my any one of the 7 standard limits? It is not there. So as usual, I mean this is not a 0. So cos 0, 1, 1 minus 1, 0, sin 0, 0, again 0 by 0 form. This is a repeated application of L'Hospital rule. So differentiate numerator as well as denominator with respect to x. 1 derivative 0, minus cos x derivative plus sin x. Sin x derivative cos x. Okay. Since by LHS. Now Sin x by cos x I did not give in my 7 standard limits formulas. Once again, put x equal to 0. Sin 0, 0. Cos 0, 1. 0 by 1 exists, 0. So, this is 0 by 1 is equal to 0. Number 2, 2016, limit n tends to infinity, root over n square plus n minus root over n square plus 1. So, in place of x variable, now it has changed, that is n variable. N is tending to infinity. So, this type of root terms I did not give my standard 7 limits, okay. Then, as usual, n tends to infinity means put n is equal to infinity according to problematic approach. Infinity plus infinity, that is infinity. Infinity plus 1, infinity. Infinity minus infinity, don't say 0, cancel. So, which is another indeterminate form. When you reach infinity minus infinity, either rationalize the numerator or denominator or cross multiplying. When you say cross multiply, you should have some denominator. Here there is no denominator. There is a root part, 2 root parts in the numerator which is with respect to difference. So, you know rationalizing factor. Root a minus root b. What is the rationalizing factor? Root a plus root b. The rationalizing factor of root a plus root b is root a minus root b. Similarly, rationalizing factor of root a minus root b is root a plus root b. Change the symbol, middle term symbol. So, what does it mean rationalizing factor means? You should multiply numerator and denominator with the same rationalizing factor of this term. That means, what I am doing is equal to limit n tends to infinity, root over n square plus n minus root over n square plus 1 into root over n square plus n plus root over n square plus 1 divided by root over n square plus n plus root over n square plus 1. Now, numerator is, looks like a plus b into a minus b. What is the answer? A square minus b square. That square and square root got cancelled. So, this simplifies limit n tends to infinity, n square plus n minus of n square plus 1 divided by root over n square plus n plus root over n square plus 1. Now, in this n square minus n square cancel. In the remaining terms, n minus 1, which is not my any 7 formulas. In that case, put n is equal to infinity again. Infinity minus 1 is infinity. Here already I told you the denominator infinity. So, numerator infinity, denominator infinity. Finally, we back to the first 2 forms only. Any indeterminate form generally reducible to first 2 forms. So, this is infinity by infinity form. You can go by L'Hospital rule. Before that, finding the derivative to the numerator as well as derivative to the denominator with respect to n, because n is variable. Or else, when the limits where the variable tends to infinity, that means limit x tends to infinity, n tends to infinity. In the problems, limits tends to infinity, convert the terms, convert all terms into inverse form, reciprocal form. Convert all n terms into reciprocal forms. What is reciprocal means? For example, see, n reciprocal is 1 by n. N square reciprocal is 1 by n square. Root n reciprocal is 1 by root n. How do you get that reciprocal terms? Take out the highest power of n in numerator and denominator. Take out the highest power of n in numerator and denominator. For example, in numerator, n and 1. What is highest power of n? That is n itself. In denominator, there is n square highest with square root. So, square root under n square becomes n. So, it is doesn't require to apply infinity by infinity. That is L'Hospital rule. What I am going to do, just limit n tends to infinity. In numerator, I have to take out n. Remaining terms simplifies to 1 minus 1 by n. In denominator, n square is highest, which is from square root, becomes n. That n is taking outside, that is common. So remaining roots becomes 1 plus 1 by n. This is plus root over 1 plus, here in place of n, we don't have n square. So 1 by n square. So now this n cancel. Everyone following? I hope that everyone following. Okay. Now, in all the remaining terms, put n is equal to infinity. Why should I do like this converting? When n is tending to infinity, 1 by n tending to 0 or not? So that's why. Now, this 1 is a constant. Limit of a constant is itself. So 1 minus 0 divided by root over 1 plus 0 divided by plus root over 1 plus 0. 1 by n square, 1 by infinity value, 0. So finally this simplifies to 1 by 2. You can apply L'Hospital rule also for this step. Example 3. This question is 1996. Limit x tends to a, x minus a whole to the power x minus a. Now, this type of terms I did not provide the 7 standard limits. Then what to do? X tends to a means put x is equal to a by problematic approach. So this is 0, this is 0. Both base and power 0. When base is some x terms, power is x terms, compared to last 3, one of these 3 indeterminate forms. So when you reach either 0 power 0, 1 power infinity, infinity power 0. Okay. What does it mean? 0 power 0 means base fx value 0, power also becomes 0. When the base is 1, power is infinity. Here when the base is infinity, power is 0. That is, in that case, the 3 terms having the same procedure. So every limit having final answer, some answer. Finally some answer or not. Let us denote that answer by y value. Let us denote the answer of the limit by any y, any term, any symbol, y or z, anything. So let y is equal to limit x tends to a, x minus a whole to the power x minus a. Understood? So this is and this is. We are comparing with our notation f of x, and this is g of x is 0 power 0 for. Then taking logarithms. Take logarithms. Log on both sides. Comma. This is log y. According to properties of logarithms, log m power n is n into log m. That is, the power should be pre-multiplied into log of x minus a. Since log a power b is equal to b into log a. And log a into b, you know that all this. Log a plus log b. Log a by b is equal to log a minus log b. Log 1 value 0. Log e value 1. Log 0 value minus infinity. Log infinity value plus infinity. Please remember at a glance, these are simplifications from 11th class logarithms. Okay. Now, what exactly this gives? This is not again my standard 7 limits formulas. Then put x equal to a. X, a minus a 0. Log 0 just now given, infinity. So this is 0 into minus infinity, or you can write 0 into infinity form. So when you reach 0 into infinity, this is only one left. Everything example over. So when you have a problem limits, product of two x terms, one x term going to 0, other x term going to infinity, then this is the procedure, 0 into infinity. So one of the product of the x terms should be shifted into denominator, will become inverse. So bring one of the numerator x terms into the denominator, then finally it will become either 0 by 0 or infinity by infinity. That is the procedure for 0 into infinity. Okay, so I can write this is some x term, this is some x term. One of these terms you have to bring into denominator. Which of these simpler term x minus a? So this can be written as limit x tends to a log x minus a divided by 1 by x minus a. Can I write like this? A into b by c can be written as a divided by c by b. That second denominator will goes to numerator. Now this is not again my 7 standard limits formulas. Once again apply x tends to a. So put x equal to a. Log 0 infinity, 1 by 0 infinity. So finally this is infinity by infinity form. So every other indeterminate form will become finally will reduce into either 0 by 0 or infinity by infinity after by proper procedure, 1 or 2 steps only. Is equal to limit x tends to a log derivative 1 by x minus a divided by 1 by x derivative with respect to x minus 1 by x minus a whole square. Since by L'Hospital's rule d by dx of 1 upon x is equal to minus 1 by, comparing with x power minus 1, then x power n into x power n minus 1, simplifies to will gives minus 1 by x squared. Okay. So fraction divided by fraction, when its second fraction will goes to numerator, will become inverse. So minus, take out, then 1x minus a cancel, will become finally x minus a. This x minus a is not my 7 standard limits, put x equal to a, will become 0. So finally log y 0, but our aim is y value. When logarithm of which number is equal to 0? Log 1 is equal to 0. So therefore y is equal to 1. What is y? Given limit. Limit x tends to a, x minus a whole to the power x minus a is equal to 1. Answer. Evaluate the following. One, 2015 limit x tends to 0, 1 minus cos of x square by 2x power 4. Number 2, 2014. Limit alpha tends to 0, x power alpha minus 1 by alpha Number 3. (2015) limit x tends to infinity 1 plus 1 by x whole to the power 2x and 4 limit x tends to 0 tan x by x square minus x. Solution. Number 1, put x square. So this function is not any one of the 7 standard limits. X square is equal to t. Since x approaches to 0, therefore 0 square, t approaches to 0. Therefore, given limit becomes, I can take 1 by 2 outside. Just like when a constant is multiplying in derivative, integration, limits, just put outside. Easy to get the standard limits procedure. Limit, or easy to proceed with the next step also. 1 minus cos t divided by t squared. So now this one is a standard limit, that is, I think, 6th formula. Please refer 6th one. In place of x we have t, in place of a we have 1. 1 by 2 into a square by 2. Refer. Standard. STD means standard. Standard limit 6. Okay. So I may forget that order, either standard limit 5 or 6. Please check. One is x power n, a power n. Second one is e power x minus 1 by x. Third one is a power x minus 1 by x. Fourth one is ln x by x, sin x by x, cos x by x. Seventh one is x power 1 by x. Fifth, sixth, I may change. I may not remember that order. I think fifth one is e power ab answer. Sixth one is a square by 2. Please check that. So finally this is 1 by 4. Next, second solution. So just compare, this is third formula, third standard limits. Put x is equal to alpha, then a is equal to x in standard limit 3. We get limit alpha tends to 0, x power alpha minus 1 by alpha is equal to, the answer that time, the answer in standard limit is log a. Now in place of a, put x, log x. That is, since limit x tends to 0, a power x minus 1 by x, answer is log a. Just in place of a, put x, in place of x, alpha. These are formula based method. Third solution. Put a is equal to 1, b is equal to 2 in standard limit 5. Okay, we get limit x tends to infinity 1 plus 1 by x whole power 2x is equal to e square. Okay, that is limit x tends to infinity 1 plus a by x whole power bx. What is the answer? E power ab. And fourth one, limit x tends to 0. Can I write tan x by x into 1 by x minus 1? Product of two x terms. X square minus x has factors x and x minus 1. That means x square minus x can be written as x into x minus 1. So, this is limit x tends to 0 tan x by x into limit of product of the functions is expressed as product of their limits. Limit x tends to 0 1 by x minus 1. So, this is standard limit is equal to 1 into 1 by 0 minus 1. This is not a standard limit. Then by problematic approach, x tends to 0 means put x equal to 0. So minus 1. Since standard limit 2. Don't confuse 5 and 6. If I do not remember that order, kindly check that. Reason is not important, but comparison is important. Next, definition. In rare type of problems, rare case, left hand limit and right hand limit. Okay. When a function containing mod x problems or bracket x problems or function defined in different subintervals. What is the meaning of different subintervals? Suppose fx is equal to tan x 0 less than x less than pi by 2 or 0 less than x less than pi is equal to minus x greater than pi by 2. That means different values of x. If you have different function fx, then in that case, these limits not applicable. Procedure is not applicable. So we should learn one more method, that is left hand limit, right hand limit. Okay. So for example, see, this is 0. What is the meaning of x tends to 0? x value is almost 0. That means either left side to 0 or right side to 0. So almost 0 means 0.001, which is right hand side to 0, minus 0.01, which is left hand side to 0. So if these two cases, the limits are same, then the original limit is also same as this. Okay. The left hand limit of f of x at x is equal to a is denoted by limit x tends to a minus f of x and given by limit x tends to a minus f of x is equal to limit x tends to a x less than a f of x, or this alternative procedure is 11th class limits, limit h tends to 0 f of a minus h. So but I am preferring this method. Okay, this is number 1. Number 2, the right hand limit of f of x at x is equal to a is denoted by limit x tends to a plus f of x and given by limit x tends to a plus f of x is equal to limit x tends to a x greater than a f of x, or limit h tends to 0 f of a plus h, where in both cases h greater than 0. Now, short form abbreviated as left hand limit not equal to right hand limit, or HL means right hand limit, then limit x tends to a f of x does not exist. Okay. Now, left hand limit is equal to right hand limit is equal to the given limit. These are one-sided limits. Okay, f of x. Now number 3, a function f of x is continuous at a point x is equal to a if limit x tends to a f of x is equal to f of a. So this limit must be exist, and what is f of a should be defined. That is fx value at x is equal to a. If limit x tends to a f of x not equal to f of a, or left hand limit not equal to right hand limit, or limit x tends to a f of x does not exist. Limit f of x tends to a is infinity. Is infinity, then we say that f of x is discontinuous at x is equal to a. I will explain one by one. In simple English language, simple notation, simple language only I am providing. If I do not explain a simple word or simple line, easy to understand, don't misunderstand me. Sometimes we have to apply for a given problem one-sided limit, that is left hand limit, right hand limit. LHL abbreviated as left hand limit, RHL abbreviated as right hand limit. So limit of the function fx at x is equal to a, I already discussed, problematic approach, formula based approach, etc. Now left, that is denoted by limit extends to a minus. When the power minus, that is indicating left hand limit. When the power is plus, that is indicating right hand limit notation. So how do you evaluate? Limit fx extends to a up to previous procedure. Then one more condition, when x less than a. So they will provide when x less than a some fx and when x greater than a some other fx. In that case, this is useful. Or this is 11th class method. Put x is equal to a minus h. That is limit h tends to 0, f of a minus h where h greater than 0. Now in the right handed limit notation is power plus. Just less than opposite greater than, minus opposite plus. Then a minus h opposite, that means plus h, a plus h greater than 0. When left hand limit, right hand limit unequal, then the limit does not exist. When they are equal to given limit. Now, already I told you graphically, geometrically continuous derivative. Now this is problematic approach, formula based procedure for saying a function f of x is continuous at a number a. X is a variable. It has so many numbers. One of the number I took small a. That is at x is equal to a. A function f of x is continuous. So find this limit for the function limit extends to a. This value exists. That answer is equal to f of a. What is f of a? Fx value at x is equal to a. This should be defined. This should be available in the question only, right hand side. Now, when these two are equal, or left limit, right limit not equal, or while finding limit if you have infinity, in all the three cases, we simply say that the function is discontinuous at x equal to a. Discontinuous means not continuous. Okay. Example 1. This question is 2011. The value of lambda such that f of x is equal to lambda into cos x divided by pi by 2 minus x if x not equal to pi by 2 is equal to 1 if x is equal to pi by 2, comma, this is given continuous at x is equal to pi by 2 is dash. Solution. So already given continuous at x is equal to a, where a value pi by 2. Fx is continuous. CONT stands for continuous, which I am using short form for the full word continuous. At x is equal to pi by 2. So this is a. So implies limit x tends to pi by 2 f of x is equal to f of pi by 2. What I told x tends to a means x value almost a. That means almost a means not equal to a. Similarly, x tends to pi by 2 means x value is almost pi by 2. Almost pi by 2 means not equal to pi by 2. When x not equal to pi by 2, which function to be considered? The top one, that is first one. Limit x tends to pi by 2 lambda into cos x divided by pi by 2 minus x is equal to f of a. That means fx value at x equal to a. This is fx value, one of these. But when x is equal to a, that fx value is 1. Okay. So what does this mean? Fx value at x is equal to pi by 2. Now, how do you find this limit? This is not my standard 7 limits formulas. Put x pi by 2, cos 90 0, 90 minus 90 0. So this becomes 0 by 0 form. So apply L'Hospital rule, take out lambda multiplication constant outside, then limit x tends to a, that means pi by 2. Now cos x derivative minus sin x, 90 minus x, pi by 2 is constant, constant derivative 0, minus x derivative with respect to x is minus 1. Okay, is equal to answer 1, since LHS rule. Now, this is lambda into sin 90 value 1, minus minus cancel 1. Therefore, lambda is equal to 1. The second example asked in 2013. Which one of the following functions is continuous at x is equal to 3? Question mark. A. F of x is equal to 2 x minus 1 x plus 3 by 3 if x is equal to 3, if x greater than 3, if x less than 3. B. F of x is equal to 4 8 minus x if x is equal to 3, if x not equal to 3. C. F of x is equal to x plus 3 x minus 4 if x less than or equal to 3, if x greater than 3. D. F of x is equal to 1 by x cube minus 27 if x not equal to 3. So the second question having 4 functions, which of these 1 functions is continuous? Solution. The first one, they are asking at x equal to 3, but you have x less than 3, greater than 3 different functions. So in this case, before finding the original limit, you have to approach left hand limit, right hand limit. So LHL. What is LHL notation? Limit x tends to 3 minus f of x. This means limit x tends to 3, x less than 3, f of x. When x less than 3, what is f of x? We are right now option yes. Option wise we have to prove. So limit x tends to 3. When x less than 3, what is f of x? X plus 3 by 3. Now this is not a standard limit. Then put, when x tends to 3 means in the problematic approach put x equal to 3. So 3 plus 3 by 3, that is 2. Next, RHL, right hand limit. That means limit x tends to a plus, where we are finding limit at a means 3 plus f of x. This is nothing but limit x tends to 3, x greater than 3, f of x. When x greater than 3, what is f of x? X minus 1. So limit x tends to 3, x minus 1. So this is not my standard limits. So this is 3 minus 1 is equal to 2. So and f of 3 is also given 2. So that means what is f of 3? Function value at x is equal to 3. So when both left limit, right limit exist, that is LHL equal to RHL. Okay. So that means equal to 3, which implies limit x tends to 3, f of x. This value is also equal to 3, but function value is also, left limit, right limit value, we got 2. 2, and this is 2. Function value at x equal to 3 is also 2. So just compare continuity definition. Limit f of x extends to a is equal to f of a. Therefore, f of x is continuous at x is equal to a. A means 3. Okay. Left limit, right limit equal means original limit is also equal to that value. That value is already a function value at x equal to 3. That is given in the question. So answer is option A. At home you check remaining 3 going to discontinuous. Here x not equal to 3. Find directly limit f of x extends to 3. X tends to 3 means this is not my standard limit. Put x equal to 3. 1 by 27 minus 27 infinity. So that's why while finding limit, if you get infinity, that is called infinite discontinuity. Similarly, you can check option C as option A. Left limit not equal to right limit, definitely you will get. All other B, C, D options definitely discontinuous at x equal to 3. Please check at home.